Alright, this is the introduction for the Ohm's Law lab, and it's relatively straightforward. It has two parts. What you're going to do is you're going to pop open the simulation right there, and you're going to set the resistance to 3 separate resistances, and you're just going to vary the voltage and see how that impacts the current. So let's go ahead and do that really quickly. So here's how you mess around with the resistance, and here's how you mess around with the voltage, and wow, look at that, it looks to me like they're proportional. Then what you're going to do is you're going to graph these guys. So what we're going to do is we're going to make sure we put the voltage on the y-axis, and we're going to put the current on the x-axis. So you can put the voltage, you're going to put the current, and it's going to be nice and straight and pretty and linear. So what you're going to do is you're going to say, wow, I know that V is equal to I multiplied by R if I put the voltage on the y-axis, and if I put the current on the x-axis, then there's a really good chance that this looks like Y is equal to mx plus B. So pretty straightforward. All you're going to do is do that 3 times. Then what we're going to do is we're going to come back here and take a look at resistivity. Something that we know is the resistivity is related to the resistance as such. The resistance is the resistivity multiplied by length divided by the area. So you're going to pop open this simulation right there and just mess around with it a little bit. And then we're going to make some measurements on resistance versus length. Just use the default settings for the area and the resistivity. I do have you record those guys right here and right here. And you pick the lengths that you want to measure. So let's take a look at this simulation really quick. So we're going to pop open to this guy right there. And what you can do is you can just mess around with the length as such. Wow, look at that. It looks proportional. So what we can then do is we can come back here and we can do this graphically. So if we were to go ahead and say, I know that the resistance is the resistivity, the length divided by the area. If I put the resistance on the y-axis and if I put the length on the x-axis, then there's a really good chance that the resistivity divided by the area is going to be the slope. So go ahead and calculate the resistivity using the slope.